So today is going to be a continuation of two things that came up in our notes Monday, which were the distance formula and the midpoint formula, both of which had to do with lines or line segments and navigating our way around the coordinate plane. So we're going to take a look at the examples of each. There's a few ways you can use both of these formulas depending on what information you're looking for. Now I have an awkward pause in my video, but that's cool. That's why they're more realistic. So we're going into more detail with the distance and midpoint formula to take a look at different information we can navigate and find on a coordinate plane, depending on what information we've been given. So we're going to start with the distance formula. So I know we wrote this down in our previous set of notes, but since it's one of our main focuses today, we're going to write it down again. So this specifically is used to find the distance in units between 2 points, x1, y1, and x2, y2. And that formula is that the distance equals, we're going to use a big square root sign here. And then inside we'll have the x2 minus x1 wrapped in parentheses squared plus, in a second set of parentheses, y2 minus y1 squared. So it looks a little scary at first because there's lots of things going on. We have first off, this big square root, this radical sign. Inside, we have parentheses, addition, subtraction, and exponents. But when we take a step back, take a deep breath, and realize that most of this stuff is just order of operations, like beginning algebra 1, we will be able to systematically work our way through it and find our calculation. So we're going to try it out right here on this first one. So this one's a little bit sly. It's asking us to find the distance between the 2 points on the graph. Now, the reason why we have the distance formula is because a lot of the times I've seen students try to just look at the graph itself and say, well, this is about 1 unit, maybe about 2, 3-ish, 4-ish, 5-ish, 6-ish. Depending on what you're doing, though, close may not be close enough. So the distance formula is going to help us get as close to the accurate answer as possible. And trying to count out units when it's going at a slant like this is not efficient at all. So what we're going to need to do is find our ordered pairs. So if I'm looking at this top left one here looks like it's 5 units to the left, 3 units up. So that ordered pair is -5, 3, and our second ordered pair appears to be 2 units to the left and 3 units down, so -2, -3.
Recording in
Now, we have the distance formula directly above it. We want to make sure we match things up carefully. So if you've had me for algebra in the past, I'm a big fan of labeling pieces so we don't accidentally scramble them as we drop them into place. So I'm going to make sure I label that this is my x1 and y1 on my first ordered pair, and then x2, y2 on my second ordered pair before I start to drop them into this distance formula that we've just written down. Again, giving myself plenty of space to work with here. Following through the prompt, parenthesis, x2 is -2 minus, because it's part of the formula, x1, which is a -5, squared, plus another set of parentheses, y2, which is a -3, minus y1, which is 3 squared. Now, if you had me in the past, I usually grumble about these double signs here. But because at this point, most of you, I believe, maybe all of you have made it through not only Algebra 1, but also Algebra 2, I'm going to leave that up to you to decide whether you're going to rewrite a whole new step, or you're going to just be careful, take that into account, or just rewrite it in there, because minus and negative does turn into addition. But for our purpose, and to save us a little bit of space, I'm just going to be extra careful with that calculation as I get there. So my distance is going to be, following me, order of operations, -2 minus a negative, which is the same as plus. So -2 plus 5 is going to give me a +3 squared, plus the second set of parentheses, -3 minus 3 gives me a -6, is also going to be squared. So today, mostly it's just about organization, following your order of operations. Still working inside that square root. We're going to do the exponents next. 3 squared is going to give me 9, plus -6 squared is going to give me 36. Then to finish up that square root, 9 plus 36 is going to give me the square root of 45. Now, like I mentioned, depending on what it is you're doing with this information, especially if you're coming from Algebra 2, there is a way we could simplify that radical. But for our purposes, we're going to say close is close enough, and we're going to approximate it, at which point, if you have a calculator handy, you would just enter into it square root of 45. But to help you guys out here today, I'll tell you that it is approximately 6.7. So the distance between those 2 points is approximately 6.7 units. Again, I said 6-ish, but some might argue it's closer to 7 than it is to 6. So if I need more accuracy than that, this will get me there. Questions so far? Okay. So let's take a look at another one. This time, instead of giving us a graph, it just flat out told us to find AB, the length of AB, given the endpoints of that segment. So I'm going to say A is going to be my x1, y1. B is going to give me my x2, y2. And I'm going to just start dropping them into my distance formula. So x2, which is 3, minus x1, which is -4, squared, plus y2, which is -1, minus y1, which is 1, squared. Order of operations, working inside here, starting at the innermost parentheses. 3 minus the -4, that's the same as addition. It's going to give me 7. Plus -1 minus 1 is going to give me -2. That is being squared as well. Again, next in order of operations, after parentheses come exponents. 7 squared, of course, then will give me 49, plus -2 squared, which is going to give me a +4. So the distance here is going to be the square root of 53, which is approximately 7.3. So, oops, not what I meant to do. So 2 examples using the exact same formula. One of them, we had to figure out the ordered pairs ourselves based off of the graph we were given. The other one just flat out said, here's your ordered pairs, plug them into your formula. So it's not the most exciting thing because it's just plug and chug, drop the numbers in, order of operations, get a value. But it does kind of make sure that you are identifying the correct pieces and you're being organized, which are also equally important in math. Third one here, again, just another example, more of the same. More negatives in there because if anything is going to trip you up today, it's going to be a negative sign because there are subtraction signs in the formula and we're dropping in negative signs as well. So be careful. But like I have so far, I'm going to label point E here to be my X1, Y1, point F to be my X2, Y2, and go right for that distance formula again. So X2, which is 11, minus X1, which is a -7, squared, plus Y2, which is 3, minus Y1, which is a -2, squared. Also, for those of you who are a little bit worried, like, how am I ever going to remember this formula? Anytime I test you on it, you'll have access to this formula. I'm more interested in, can you use it, not can you memorize it? So yet again, following our order of operations, starting inside with those innermost parentheses, 11 minus a -7, which is just 11 plus 7 is going to give me 18, squared, plus 3 minus a -2, which gives me 5, squared, exponents next. According to my notes here, 18 squared should be 324. Hopefully someone out there's at least halfway fact checking me. And then 5 squared gives me 25, which means my distance is going to be the square root of 349, which is approximately 18.7. So there's the last 2 examples that we did. So those are a couple examples of the distance formula. Again, the distance formula just is what it is. All we really use it for is plugging in information we know, typically to find the distance. But as we'll see here in a little bit, there's actually a way to use the distance formula to kind of work backwards. Actually, nope, it's not on today's. So I'll just talk about it real quick. In theory, hypothetically, I could figure out if I knew the distance I wanted between 2 points, I had the coordinates of one point, but only one coordinate of the other. Hypothetically, I could work through it to be able to solve for a missing coordinate. I will say it's not as easy as this part because the distance formula already, as its name suggests, is designed to find the distance. Using it to find one of those other pieces would require a little bit more manipulation, but could be done. I forgot, we don't do that with the distance formula though today. We're going to use that process sort of for the midpoint formula, which is our next topic. Yes?
I have a question.
Sure.
You know how we look or wait, 349 for example, and then you said approximately 18.
How am I getting that?
Yeah.
So good question. So if you guys didn't hear Denise, yes, she said, where we go from that square root of 349, where the heck did that 18.7 come from? Just a calculator. There is a way to approximate if you know your perfect squares, which once we get to that large number, I don't even, without a little bit of work, I don't know. So I would grab just a scientific calculator. I think even basic 4-function calculators have a square root button. You would put in square root 349, and on my calculator, it's reading 18.68154169, and that would actually go on forever. Nearest 10th or nearest 100th is going to be good enough for me, just so it's not an annoying number to carry through. But yeah, that approximation is just coming from a calculator. Good question. I did just kind of throw it in there to say, yep, that's approximately this. How's he know that? Well, I know it because I wrote it down once. But if I needed to find it again, I would grab a calculator and calculate the square root.
I was checking.
You're checking me? Good. Everything looks good then so far? Perfect. I'm glad you guys are watching. Don't just believe me because I said it, because what do I know? Just because I sit at the desk here doesn't mean I'm but I always invite questions, because sometimes I just do it because I was told to do it. When students push me to understand something, that's when I still get to grow too. We should never stop growing. So yeah, good question. Good question. So we're only focused on 2 formulas today, so not having to worry about 3, 4, 5, 6 different formulas and choosing when to pick through them. Just 2. Distance formula is one of them. The second one is our midpoint formula, which is specifically designed to allow us to find the midpoint, which from 2 days ago, we talked about how that is a point that is exactly between 2 other points, exact middle. And that's assuming that you have the coordinates of those 2 endpoints. So again, we're still working with coordinates again. This time, instead of figuring out how far is between them, we're trying to find the point that's exactly in the middle. That formula looks a little bit different. So the formula is actually designed to give us an ordered pair. So it's kind of like there's 2 parts to it. So I like to say that this is finding our midpoint. I usually identify it with M, but because it is an ordered pair, I'm going to write it like a large ordered pair, where my first x coordinate, where my first coordinate, which is the x coordinate, is x1 plus x2 all divided by 2. In other words, the average of my 2 x coordinates. My y coordinate, very similar, is just y1 plus y2, also divided by 2. So in other words, the average of my y coordinates. Because the thing about averages is you're trying to find basically the middle-ish amount. And by finding the average of these 2 coordinates, you're going to find the exact coordinates as to where your midpoint is. So we're going to take a look at this in action. Again, probably good practice to label those ordered pairs so you don't accidentally mispair them. Happens more often than you think, even with someone who's used the formula several times. So here it's asking us to find the midpoint of segment GH, given the endpoints G and H. So G, I'm going to say, is going to be my X1, Y1. H is going to give me my X2, Y2. And then I'm going to work a little bit more horizontally for this one, just because of the space provided. But I'm going to say that my midpoint is at the ordered pair X1 plus Y1. So 7 plus 9 divided by 2 comma, y1 plus y2. So -5 plus a -1 also divided by 2. Now, technically we found it, but it's a hot mess. I wouldn't know where to graph that until we go through and clean it up. So 7 plus 9 gives me 16 over 2. And -5 plus -1 give me a -6 over 2. And I take it one step further because those will actually divide quite nicely. My midpoint, 16 divided by 2 gives me 8. -6 divided by 2 gives me a -3. So if I were to graph these on a coordinate plane, first the two endpoints, connecting them with a segment, and then I were to find the ordered pair 8, -3, that point would be exactly in the middle of that segment. Now, I will tell you, most of the problems I give you with these formulas will come out to be fairly clean numbers. But as most of us probably could figure out, in the real world, measurements rarely come out to exact whole numbers. So decimals and fractions are fair game, even though some of these are designed to be nice, pretty numbers. So don't panic if you get a fraction or decimal. Just check the math. Make sure that it is, in fact, correct. Questions on that one? Let's try one more. Another segment, AB. So A is going to give me my x1, y1. B is going to give me my x2, y2. Dropping those over here into my formula. X1 plus y1, I'm looking at -7 plus 3. Divided by 2. Y coordinate is going to be y1 plus y2, so 4 plus a -4 over 2. Once you got the pieces in place, just a matter of cleaning them up again. So my midpoint, -7 plus 3, I believe will give me a -4.
That's 0.
And the second one will give us 4 plus -4, which is 0 over 2 as well. So the last one here, just to clean it up further, especially since these do divide nicely. -4 divided by 2 is going to give me a -2. 0 divided by anything really is going to give me 0. So that's the second of our formulas today. So distance formula, as its name suggests, allows you to find the distance between 2 points. Midpoint formula, as long as you understand what a midpoint is, allows you to find exactly that. So as long as you're finding those two things, these formulas are designed perfectly to do that. However, sometimes we got to get a little bit clever and use these formulas to allow us to find pieces that we don't have. So the midpoint formula can actually allow us to find a missing endpoint, assuming that we have one of the endpoints and the midpoint itself. Now, why would I want to do that? Let's say hypothetically, on a coordinate plane, I have a segment with 2 endpoints, but instead I want to double the length of that segment. Well, I need basically that same distance just attached further. making one of those endpoints then technically the new midpoint. So having it identified as such, we can set up a formula here that allows us to figure out what the new coordinates of that new endpoint would be using the formula we've been given. So finding a missing endpoint. It is asking us to find the coordinates of A if the midpoint is at -1, 2, and it is the midpoint of AB for which B has and B has the coordinates of 3, -5. So in other words, we know that this will be true. Let's see, how am I going to write this? So off to the side here, I know that my midpoint is -1, 2. But I happen to know, according to the midpoint formula, we have to have an x1 and a y1. Is that correct? We have one endpoint only. So I'm going to say that this is my x1, y1, and say we're missing our x2, y2. So in that formula, I know x1 plus my missing x coordinate divided by 2 would be paired with my y1 plus my missing y coordinate divided by 2. Right now, it looks like I created a hot mess. But here's the good news. I know two things to be true. I know that if that is in fact the midpoint, I know that this -1 is going to have to be the same as this x coordinate right here. Because according to the midpoint formula, that gives me the midpoint for which I already know the x coordinate. Secondly, the same is true for the y coordinate. If I know the y coordinate for the midpoint, it must be equal to what I would have gotten had I known both x's and y's from the beginning. So now we got to do a little bit of legwork. I now know two things to be true. I know that -1, oops, wrong tool. I know that -1 equals 3 plus x divided by 2. And I also know, yes, I also know that 2 equals -5 plus y over 2. And that is a relationship between the midpoint that we know and the formula for which we filled in all the pieces that we have. What we end up with are two equations that we should be able to solve. Starting with the x, so the one here on the left. Trying to get x by itself, what would you move first? I would certainly get that too. Make it stop looking like a fraction. So it's currently being divided. So I'm going to do the opposite and multiply both sides by 2. So 2 times -1 on the left will give me -2. On the right, the times 2 and the divide by 2 get rid of each other, leave me with just 3 plus x. Then what? Still trying to get that variable by itself, right? So we're going to subtract that 3 from both sides. So -2 minus 3 gives me -5. Bring down my x. I end up finding that x, or in this case, my x coordinate that I was missing, is -5. run through the same process for the y coordinate. Very similar feeling. Got to get that 2 out of the way first. So I'm going to multiply both sides by 2. Which gives me 4 equals -5 plus y. And then get that y by itself. I'm going to add 5 to both sides. Gives me 9 equals y, or in other words, y equals 9. So where's my other endpoint? A. What did I just find? Found 2 parts of my final answer. A is located at -5, 9. I'm gonna give you a second to jot that down, but then I'm going to show you real quick visually what's going on here. To see that, oh, right now it just feels like a bunch of random numbers. There's no image to go with it. I'm going to show you what's happening here in just a second. So, find my calculator here. So we started off with midpoint at -1, 2. We were given the coordinates for B to be 3, -5. And we were looking for A. Well, if I were, trying to predict, I'd say it would be somewhere up here in this region if M truly is the midpoint. So through that process, we worked our way through it. We came up with the coordinates -5, 9. Does that appear to indeed be the midpoint between those 2 points? Certainly does. But instead of trying to sketch it out and kind of like grab a ruler, approximate, measure with our eyes, we found the exact midpoint. Excuse me, we already had the midpoint. We found the exact endpoint for which that M was our midpoint. So it takes out the eyeballing and the guessing and trying to sketch. It takes you right to the exact answer. So I'm going to try the next one here with a little less color coding. Here we've been given the coordinates of J, find the coordinates of J if K, which is -5, 10, is the midpoint. I probably should underline that because instead of M, they use a different letter on us. That was sneaky. So K is the midpoint of segment JL, and L has the coordinates of -8, 6. So there's one of my endpoints. That's going to be my X1, Y1. Which means if my midpoint is at -5, 10, it's going to have to equal what we would have calculated had we not known the midpoint. So we would have taken the X that we know plus the X that we don't know and divided by 2. And then the Y that we knew plus the y that we don't know, also divided by 2. Which in turn gives us the two equations, -5 equals -8 plus x divided by 2, and that 10 will have to equal 6 plus y divided by 2. Once you have the relationships in place, it's just a matter of calculate, 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 solve the equation. So starting on the left here, I'm going to multiply both sides by 2, which gives me -10 equals -8 plus x. Add 8 to both sides. Gives me -2 equals x. Or in other words, x equals -2. And then I run through it with the y. I'll multiply both sides by 2. I get 20 equals 6 plus y. Subtract both sides by 6. I get 14 equals y. So y equals 14. So we had the midpoint. Our midpoint was K. We were looking for endpoint J, knowing already where L was. So our coordinates for J are at -2, 14. Questions so far? Algebraically, once you get the equations, it's algebra 1. The hard part is setting it up or using those relationships to set up your equation in the first place. Tell you what, I'm going to skip over number 8 because it's no different than the other two. Same setup. If you want to try it out, I will tell you, if you want to challenge yourself real quick, that the coordinates for R, which is what it's asking you to find, are -7, 0. If you want to try that one out on your own, knowing what the answer is, you're more than welcome to. But for the sake of time and giving you as much time as I can to start the assignment today, I'm going to jump ahead to our last little section, which is using algebra and applying it to our geometric understanding of midpoints and bisecting and things like that. For more practice, number 9 here says if P is the midpoint of segment XY, XP equals 8x minus 2 and PY equals 12x minus 30, find the value of X. That's a whole lot to take in. That's a whole lot of letters. So what I suggest in these situations is if a diagram is not given to you, start sketching one out. Because sometimes seeing it all together in a picture makes it a little bit easier to start to identify the relationship that's being used here. So I've been told, first thing, P is the midpoint of segment XY. So I'm going to draw a segment here. XY. I'm going to try to eyeball best I can where the midpoint is, which has been told to be labeled P. And let me ask you real quick. Actually, let's do this. Underneath, we were told that XP is 8x minus 2. And we were told that PY is 12x minus 30. But what it is relying on now is based off of one very important keyword. It's midpoint. Remind me again, please, somebody, what is a midpoint? What's that? Not quite. So that would be an intersection point. Exactly in the middle between two other points. Now, let me ask you this. If you cut something exactly in the middle, what happens to those two pieces? They're split in half. They're split exactly in half. And the word half seems to suggest that they should be equal, right? If you cut something perfectly in half, those two halves should be exactly the same. Now, from a few days ago, there was notation I used to represent that something is actually congruent, those little hash marks. So we know, because we've been told that P is in fact the midpoint, that means that XP and PY are congruent segments. What does it essentially mean to be congruent? Couple words you could use. Say they're the same, they're equal, which is nice because I know something about XP and I know something about PY. And if I'm now saying that they must be equal to each other, then I must be able then to state that 8x minus 2, which is XP, must equal 12x minus 30. Now, if you want to see the geometry symbols behind that, that is basically me saying that segment XP is congruent to segment PY. But because I am now saying, well, because of midpoint, those must be congruent, I can then express that those two expressions must therefore be equal to one another. Well, inadvertently, then I set up an equation which should allow me to solve for X. So if you had me for algebra, I'm going to run through the same steps I used to go through. Do you see any parentheses? No. Any like terms? Technically not, because they have to be on the same side of an equation in order to be considered like terms. Third thing is the variable on both sides? Sorry? They're not on the same side. So I need to move one of those. And usually I recommended moving the smaller of the two. Just avoids a negative later on. So I'm going to move the 8x by subtracting it from the left. But because it's an equation, I'm also going to have to subtract it from the right. So it's gone on the left-hand side, leaving me with just -2. On the right, 12x take away 8x is going to leave me with 4x, and then -30 falls down. Now we just got to get that variable by itself. So I'm going to add 30 to both sides. So -2 plus 30 gives me 28 equals 4x. And then I'm going to divide both sides by 4. So off the side here, we end up getting x equals 28 divided by 4, which is 7. So again, it depended on us recognizing the definition of a midpoint and what that means then for the segment as a whole, as well as its parts. Second one, very similar, is saying if G is the midpoint of FH, and we know that FG is 14x plus 25, and GH is 73 minus 2x, find FH. So this one's a little bit more advanced. It's not just asking us to find the missing variable. We're going to need to find it first in order to find the measure of the segment completely. But it helps to have a diagram. So we have segment FH, for which G is the midpoint. And if G is the midpoint, that means FG and GH are congruent. And we were told that FG is 14x plus 25. GH is 73 minus 2x. So we know, based off of the definition of midpoint, segment FG must be congruent to segment GH. We're going to use that fact to set up our equation. So now that we know this relationship, I'm going to go ahead and set up the equation 14x plus 25 equals 73 minus 2x. And I go into solving mode. So no parentheses, no like terms, but my variable is on both sides. I usually like to move the smaller of the two. So I'm going to add 2x to both sides. So 14x plus 2x gives me 16x plus 25 equals 73. And then I'm going to get that variable by itself. So I'm going to subtract 25 from both sides. Which I believe is 48. And then divide both sides by 16. I get x equals 3. Now, here's the catch. Did it ask us to find x?
No.
No. What did it ask us to find? FH. Now, so here's where the diagram kind of helps us a little bit. FH is this entire segment. Any ideas how X is now going to help us find that? Sure, we could plug it in. We have a couple options, actually. I could plug it in for both of these X's and add it all together. Missy, I'm curious, what do you mean? Why could we do it with just one?
Save more time.
And if we find one of them, though, would that be our answer, or would we have to do something with it? So if I just plugged it in here, that would give me FG. But if I go back to my definition of midpoint, FG, what's that? The two halves should equal the same thing. So in theory, if I found one of the halves and just doubled it, I'd have the whole thing. So absolutely, it would save me a little bit of time. Now, Shanitha, if you plugged it into both and added them all together, you'd still get the same answer. Oh, yeah, no worries. So I'm going to use the 14x. Oops, that's not what I wanted to do. So the FG is 14x plus 25 I now know what x is in this situation. So I have 14 times 3 plus 25, which that's what, 42, I believe. Plus 25, which gives me 67. So FG is 67, which is only half. So I double it. So in other words, times 2, and that's going to give me FH equals 134. So sometimes the hardest part of these problems is remembering what it is you're actually looking for. So usually, especially coming from algebra, we solve for a variable, we celebrate, we're done, we move on. Geometry, sometimes it asks us just what that variable is, but other times it then asks us, what's the measure of this segment or these other pieces for which that variable is then used? All right. Last one actually gave us a diagram as well. It's using a little bit of different vocabulary here for us too. So the diagram we're given, we'll just look at that real quick. We have segment QR, for which we have the two parts of that segment labeled 3x plus 5 and 5x minus 19. Bless you. It also appears that we have line N intersecting segment QR at point P. Now, right off the bat, if I just gave you this diagram, can you set these two equal to each other?
No.
Why not?
I don't have a midpoint.
We don't know. We don't know if it's the midpoint. P might be the midpoint, but do we trust our diagrams?
No.
We do not. Until there's a way I can either prove that P is the midpoint or there's some sort of little hash marks on there or notation or something, don't assume that that's what you're gonna do. So that's where we read the statement here. It says, using the diagram to the left, if line N bisects QR, find QP. There is a word there that I really am hung up on.
Yeah, I'm trying to find it in the notes.
Bisects.
Yes.
The word bisects more or less means cut in half. So in other words, although it didn't come out and say that P was the midpoint, if that line is bisecting it, it is crossing that segment exactly at the midpoint. So because of that one word, we are then allowed to come over here to our diagram and say that QP and PR must be congruent. Therefore, P is the midpoint. In order to bisect something, you have to go right through its midpoint. Now, with that information, now can I set 3x plus 5 equal to 5x minus 19? Sure. With reading the text and updating our diagram, we now have enough information to safely say, yep, those are in fact equal to each other. So off to the side here, I'll say 3x plus 5 equals 5x minus 19. And then I go into algebra mode to solve. So no parentheses, no like terms. The variable is on both sides, however, so I'm going to move the smallest by subtracting 3x from both sides. Leaves me with 5 on the left-hand side. On the right, 5x take away 3x gives me 2x. Drop down to negative 19. And then getting that variable by itself, I'm going to add 19 to both sides, which gives me 24 equals 2x. Divide both sides by 2. And because we're not in algebra 1 anymore, I'm going to do a double switch here. I'm going to say x, go and flip it and solve it. X equals 12. Are we done? Why not? I found x.
Not what it's looking for.
That's not what it told us to find. Now, did we need x?
Yes.
Sure. We needed that missing piece of information, but we are going to plug it in. And it did say find QP. So we're in luck. QP is right here. All we need to do is plug it into that 3x plus 5. So off to the side here, we know QP is 3x plus 5. And we now know that x is 12. So I have 3 times 12 plus 5, which is 36 plus 5, which I believe gives us a total of 41. Just like that, we found the piece we're looking for. So those of you, at least those of you who have been more vocal, good job. You're not just falling for it like, oh, I found the variable, oh, I'm done. Make sure if you think you're done, go back and reread the problem at least one more time and ask yourself, did I find what it asked me to find? Sometimes it may feel like you're done, but you got to go just maybe 1 or 2 steps further.